Welcome. My name is Lauren Fillmore. I'm a program director at the Water Environment Research Foundation. The anaerobic digestion of biosolids to produce a methane-containing gas called biogas is an established technology. That gas production is a very important component of our sector's ability to become a sustainable green sector. Biogas contains contaminants that need to be removed before we can actually generate heat and power. The equipment manufacturers have very specific requirements for removing contaminants. However, the technology to remove these contaminants can be very expensive. And sometimes the economics of all this different type of pretreatment technology shifts the viability of these projects, and they're no longer able to go forward because of the cost of pretreatment. One of the key classes of these compounds are called siloxanes.
Siloxanes are organic compounds with silicon. Here is an example of two types of siloxane compounds out of the 9 siloxane compounds that show up commonly in biogas. Siloxanes have low solubility in water and are resistant to heat and oxidation. They absorb readily to biosolids. The increased use of materials containing polydimethylsiloxane in products such as food additives, detergents, and personal care products has led to an increase of siloxane-containing substances in biogas. The digestion of these solids under oxygen-free conditions is called anaerobic digestion. Anaerobic digestion is a solids treatment process that stabilizes the organics, destroys pathogens, reduces the quantity of solids, and creates methane, which can be collected as a biogas and used for renewable power by various cogeneration technologies. During anaerobic digestion of wastewater residuals, the siloxanes volatilize and end up in biogas. When the biogas is in equipment for combined heat and power, siloxanes are transformed to a precipitate, which clogs the unit, interferes with energy recovery, and causes damage. This slide shows chip equipment clogged with siloxane buildup. Increasing siloxane concentrations in biogas increases maintenance and the associated costs to remove the deposits. These issues are complicated by the fact that most biogas cleaning technologies are not specific to siloxane removal, and there is a lack of standard sampling and analytical protocols for reporting siloxane concentrations in biogas. This project will result in guidelines for sampling and analysis of siloxanes in biogas, as well as recommendations to improve biogas treatment efficiency. This project is a collaboration between WRF and Suez Environment's subsidiary Infilco Degremont, who will conduct the field demonstration task. We are at their R&D center in Richmond, Virginia, but we will travel to Suffolk, Virginia to see more.
The Nansemond Treatment Plant is located in Suffolk, Virginia, and discharges to the James River, which is a tributary of the Chesapeake Bay. HRSD is happy to participate in this WRF study because it gives us an opportunity to reevaluate our use of digester gas.
The field demonstration that you are about to see evaluates the effectiveness and economics of various siloxane removal media in a side-by-side comparison with granular activated carbon and investigates the effect of media shapes, size, and gradients. The team will also investigate the impact of chilling temperatures and hydrogen sulfide content. Let me introduce you to our team leader.
The standard vaporized activated carbon was used to clean the biogas, mainly siloxane. But nowadays there are more and more media that have been introduced into the market which claim that they have a higher capacity in siloxane removal. They are more efficient, more cost effective. But till today, not a single study which documented the side-by-side evaluation of granulated activated carbon with different silica gel or different media which is available for selection environment. So this study is to look at, the first thing is what is the effective selection removal capability of each and every media. We will study side by side GAC and different media. So the pilot is connected to actual digester biogas. So the inlet of this pilot is coming from a digester gas. As you can see, it follows from here, and then it goes into, from there it goes into a smaller plate frame type of heat exchanger, where it cools down further from 35 to 25 degrees centigrade. From that heat exchanger, it goes into third heat exchanger, which has a glycol chiller type of application, and it is drop down temperature from 25 to 10 to 12 degrees centigrade. After that, it goes into a condensate trap where all the condensate is removed, and we are collecting that condensate also and measuring it. If any condensate it is, any siloxane is removed from condensate also now. From that, it goes again into the same plate heat exchanger, where it is reheated to 25 to 30 degrees centigrade, and from there it goes into two parallel siloxane removing vessel. Again here, the treated biogas enters from the bottom of the vessel. Currently we are testing two different types of silica gel. The one is irregular and the one is more spherical. They are designed in such a way that they are in three different layers. Each layer has a different pore size and different particle size. So as it travels up, all the selection is absorbed, and when the gas leaves from the vessel, basically it should not have any siloxane. There are 5 sampling ports along the depth of the vessel, and the reason we installed so many sampling ports because we wanted to study the bed exhaustion capacity and how it is being exhausted. So there are 5 sampling ports. We collect samples regularly and we analyze the bed capacity of each media we are testing it.
The media that will be tested includes several types of silica gel products with different shapes, such as ball or irregular shaped, various surface areas, and pore volumes. The team will use activated carbon for comparison. They will examine hydrogen sulfide removal media, and they will also test a new media called Dowex, a polymeric absorbent specifically prepared to remove siloxanes. Researchers and technical advisors examined one of the silica gel media. This is Dowex, activated carbon, additional silica gel media. A researcher tests gas samples for siloxanes in the Infilco Degremont laboratory.
I'm here with the advisory committee members from the siloxane project.
We at HRSD have had several digester gas to electricity projects in the past, and some of those have not worked out well, primarily as a result of poor gas quality and the need for better gas treatment. We're in the process of now designing about a 2 megawatt facility at one of our treatment plants, our Atlantic plant, and we're hoping very much to use the information and what we've learned from this project about gas treatment to guide the design and the media selection for siloxane and hydrogen sulfide removal. So we're very fortunate to have this project here, and we're anxious to learn all we can about siloxane and sulfide removal.
Field work is still underway, but this project has already resulted in one report that is currently available. This report focused on potential benefits of biogas as an energy resource, including use as vehicle fuels. Along with the state-of-the-art on biogas treatment and cogeneration, the report has information on high-temperature fuel cells using biogas as a fuel source. For updates on this project and more, go to the Operations Optimization Knowledge Area page on the WRF website.